You're kind of right. It's right around 6:50.
I feel like that's one of the main things.
Is it Tuesday only?
Yeah.
Oh.
All right, strings and text files. Tell you what.
Which lecture is this again?
This is chapter 4, beginning chapter 4.
You meant one letter.
Yeah.
Oh,
After J.
good question.
I think it's part
Is
of
this K?
lecture L.
I think it's K. Let's go look.
K.
JK.
One of those letters.
I'm
Yeah.
just gonna say
Wrong K.
lecture kilo.
That sounds right. All right, so what is a string? It's just a series of characters, like keyboard input, right? Like text that is read from the internet. A string is just a series of ASCII values, like this. Hi there, right? And if we went to ASCIItable.com, we could see that a capital H is a something, and an I is a something else, and a space is a 20, and a T is a something else, and so on, right? All the way through. So it's just a series of bytes that, in sequence, form some kind of information that we can understand. So each spot in a string has what's known as an index number, or a subscript. So here where we go, hi there, the first character, the first index is actually 0. Computers don't count 1 to 10, they count 0 through 9. So 0, 1, 2, 3. So the first one is at position 0, the second one's at position 1. The third one's index 2, sometimes called subscripts. If I ever say subscript, I mean type the things between the square braces, and so on. So if we were going to do something like that, and then I do, name equals Fred, name subscript 0 is F, name subscript 1, R, name subscript 2, E. You can see where this is going. Name subscript 3 is D. So what's the highest subscript that was allowed? 3. The highest index position is equal to n minus 1, where n is the length of the string, right? And so the length of the string is 4. So we were able to count 0, 1, 2, 3. What if we wanted to get that length for some purposes? We could type len. That's the built-in function that calculates the length of a string. And in fact, it is 4, which is why we were able to go 0, 1, 2, and 3. Can you have something with a length of 0? Yeah, actually you could. What if you did this? Naming is equal to quote, quote. And then if you do the length of that name, 0. There's no data in it. Now this language has a strange feature that no other language I've ever used has, which is that it can start counting from the end of the string rather than at the beginning if you use a negative number. That's index position -1. That D. That's index position -2. That one's -3 and that one's -4. So since I reset name, it doesn't have any possible values, right? So let's just play with this. I'm going to type in Vader, end quote, subscript -1 in subscript. And that's the R. In this case, I didn't bother storing it in a string ahead of time, and I almost always will, right? But what I did is I had that piece of data, and then I said, okay, I want the -1 character, which is that one. And if I did -2, it would be that one. -3, it would be that one, and so on. But normally, I'm not going to just have a solid string like that, followed by an index. Usually, I'll store it in a variable, right? Name equals, quote, Vader, end quote. And then name subscript -1 is going to be that R. And name subscript -2 would be the E. Name subscript 3 would be the D. Name subscript 4 would be the A. and name subscript 5 would be the V. So name subscript -5 is the V. So if you want the last character of a list or of a string, and a string is almost exactly a list of characters. There's a couple of differences in the way that they're treated, but when I use the term list, it's just a series of elements, and a string is a series of characters. If I wanted to print this R out, there's a couple different ways I could do it. One is I could get the length of the string and subtract 1 from it, like this. N is equal to length of name in subscript -1. And then I could do name subscript n, and that'll get me the R. Maybe you can see where the -1 feature came from, right? Because -2 would have gotten us the E, -3 would get us the D. So that's one way to do it, or you can just do name -1, which is a little bit easier, right? Cool feature. This language, I've never seen another language that does it that way. So example. Name is equal to Alan Turing. Name subscript 0. That'll be the first character. Name subscript 3. That'll be the fourth character. Let's count to make sure. 0, 1, 2, and 3. Yep. So that's the N. Name, LEN name. Oops, that's an index error. Well, what are they doing here? Well, what's the length of the name? The length of the name, it looks like, is going to be, I could be wrong, but I think it's 11. 1, 2, 3, 4, 5. 6, 7, 8, 9, 10, 11, right? So when we did name, length of name, that's the same thing as name 11, which is 1 past the end, because you start counting at 0, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Name subscript 10 would get us G. Name subscript 11 gets us an error. So if you want to loop through a string, a couple of different ways you can do it. They're showing one way here. It's not necessarily, there is an even shorter syntax. About time to start playing. File, new file, save as Lecture K. So I'm just going to create a string, and I'm going to call it a S. And I don't care what's in here. Right, like that. If I want a loop that's going to process every character in turn, like if I'm going to do a Caesar cipher on it, or who knows what I'm going to do, I could do it with an index-based loop, or I could just use a for loop. Now I just said that. I hope it's actually true. For CH in space S colon print parentheses CH in parentheses. Let's make sure that works. I think it does. And you see what it said? It says, I don't care. What is this for statement doing? Well, what does for in general do? The for loop steps through a series of predefined values. If it's a range, it steps through a predefined range. If it's a list, it steps through all the values of the list. In this case, it's a string, and so it steps through all the letters in the string. That's why we get I don't care. Or you can use its index, and that's what the textbook shows. And this is a little bit more traditional computer science-y to do it like this, because not all languages have the facility to step through the individual letters of a string like that. And so that would look like this. For, and I'm going to use I now because it's an index value. For I in range, parentheses in parentheses colon, and what am I going to put inside the parentheses? The length of the string. So len parentheses s into parentheses. And then I could print out s subscript I. Print parentheses s. When I say subscript, I mean open square I close square close parentheses. And that'll do the same thing. It'll print out the same letters 2 times in a row.
Run it.
Whichever one you want to do in a case like this is entirely up to you. I'd be kind of tempted to go for this just because it's a lot less typing. But if you ever need the index number for some reason, then you might want to do it that way. If you wanted this loop to look even more like this one, I don't know why that would be the case. But we could have stored that variable like this, ch is equal to s subscript I, and then print out ch. And if you compare that third one that I made by copying and pasting and that one, right, you can see what it's doing. It's copying each letter that's in the string into a temporary variable called ch. See, that's that copy, and then it does something with it. So let's print out all the ASCII values of the character. I'm going to use this syntax just because it's easier. For space ch space n space s colon print parentheses in parentheses. I'll tell you what, I'm going to store it in a temporary variable. I'm going to call it AV for ASCII value. AV equals ORD parentheses CH NCH. This ORD is the ordinal value of that character, which is the ASCII value of it. And so in the next line, if I say print AV or print CH comma AV, hey Siri.
Oh, man.
There we go. So when we run it, it didn't do a darn thing that I expected it to do.
Yeah, let me see. Indicate.
Oh, no, not getting it. Did it get to that loop? Print parentheses quote ASCII values quote in parentheses. Oh, there. How about that? Okay, there we go. Right. And so where it says I don't care, a capital I is a 73, a space is a 32. Earlier, if you caught me saying that a space is 20, that's the hexadecimal value of it. We can go and we can check all these really easily by opening up ASCIItable.com. And so an I, an uppercase I, is a 73. A space is a 32. A lowercase d is a 100, and so on. Once you have the ASCII value of it, you can do tricks with it. You can do things with it. You could add 1 to it, add 2 to it. You know, if you add a set amount to it, if you shift it by a set amount, you're doing what's known as Caesar's cipher. So what if we took every letter? Let's reset our string though to something else other than I don't care. That's kind of negative, isn't it? All right. So instead up here, I'm going to make this say S equals I love my ABCs. End quote. Like that. And so that's what it says. I love my ABCs. Once you have the ASCII value of it, you could use it to create another character.
What did I do?
I'll come right over. So I'm going to say CH is equal to the CHR, the character value of that ASCII value plus 1. I'm going to shift everything over just by 1. And so then I'm going to print CH comma, I said CH2 and I accidentally typed CH. CH2 is equal to the character value, character parentheses AV plus 1 in character. And then I want to compare the original character to the new one. So you see what I'm doing here? I'm creating a character that shifted one greater. So A's become B's, B become C's, and so on.
I think I have a problem.
And here we go, where it says, I love my ABCs. The easiest, the most blatant part of it is where A becomes B, B becomes C, C becomes D. Right? So, this has been enciphered. Right? It's a little bit harder to read. Now, we could look at it and try to figure it out. One of the ways that you can try to crack a Caesar cipher is you can just see what the most popular character is. The most popular character in text is the space in general. And so if you say, well, a space is the most popular one that I have found, then I'm going to treat all the spaces and I'm going to figure out what the value is that, in this case, the exclamation mark, right? The exclamation mark appeared more than anywhere else. So, okay, if that was supposed to be a space, but it's an exclamation mark, that's a 33, that's a 32. Subtracting one from everything would crack the cipher. So this plus 1 could be anything. Plus 10 would shift everything to the 10s. I mean 10 over. And I better do a walkabout. I see some people looking like they have syntax errors. I can just smell them. All right, so here we go. Right? S is 10 characters greater than I. A V is 10 characters greater than L. And O is 10 characters greater than E. And I'm not going to actually count them, right? But we know. That's about sure. Right? A to K, A, B, C, D, E, F, G, H, I, J, K. Right? It's 10 characters more. And so ABCs here becomes K, L, and M.
Then S becomes a curly brace.
Yeah. So, there's a problem here. What if we made this say, I love ZZ Top? Alrighty. I made the Z's lowercase, by the way, on purpose. And that's because when I run it, you see these ZZs became blanks. They actually became a non-printable character. The non-printable character is because the ASCII chart, the 7-bit ASCII chart, stops at 1 past Z. So if I go back to ASCIItable.com, well, not 1 past Z, but anyway, so there's Z, it's 122. If you go 10 past it, 123, 124, 125, 126, 127. Well, I needed to get all the way up to 132, and I can't. If I did, I'd go out into this la-la land of extended ASCII codes. And you never know if your character set has extended ASCII codes or it has other garbage appeared at the end. Now, this particular character set was so that you could draw character-based menus, you know, like an old-fashioned terminal, and you could have squares, you know, and rectangles and stuff like that. You can get some of these values by holding the Alt key down and using the numeric keypad. Some of y'all may be used to the idea of, like, if you hold the Alt key down and type in 254, you might get that thing. But I'm going to try that out, so I'm going to press numlock on my keypad to make sure that it's a number, and then I'm going to hold the Alt key and type in 254 and release, and I get that square, right? And so I should be able to get any ASCII value. Like, that one's pretty funky at 176. Hold the Alt key, type 176, let up, and you get that. But when we tried to print out character 32, Python did not display an A with a diacritical, an umlaut, or whatever that's called. Instead, it just printed out a blank. It didn't know what to do with it. So we need to stop that value from getting greater than 127. So if we got a Z, if our result is greater than 126, we need to reset it all the way back down to 32. So if we got to a 127, we need to get it to be a 32. Now my brain's not working good enough to see what 127 minus 132 is, although it's an easy problem. If our value is greater than or equal to 127, why did I type 132? 127. If we subtract 95 from it, it'll wrap it back around to an A. So our processing is getting a little bit more complicated here, right? Because we're modifying this value over and over and over. Why don't we call that our shift value? So over here, somewhere I need to declare my shift. So shift equals 10. And I said I was going to walk around. Let me make this one last change. I'm going to edit that line right here to make it say AV plus shift. And by the way, if you have a shift of 0, it means that the characters weren't shifted at all. So when it runs, I'm going to see my I love ZZ Top message just like that. And if I make it -1, then we're going to see everything shifted backwards, where the ZZ Top becomes YY whatever. Right? ZZs become YYs. The spaces here, the space is the lowest value that we want to see on our ASCII table, which is a 32. Because a 31, a unit separator, it has no idea what a unit separator is, and this is very specific to some kind of transfer protocol. These are control codes. We don't ever want our ASCII value to become less than 32. So if it's less than 32, we want to add a value to it to knock it up to be 126. And I think I could do that by adding 95 to it. So like if it was 31 and I added 95 to it, 31 plus 95 will get me 126. And so if I look back over here at my ASCII table, if we subtract 1 from it, where's the 31? There it is. We subtract 1 from it, we get a 31, but then we add our 95 to it, we get 126, right? And then if the shift value had been -2, -3, -4, so we're going to have some if statements based on our resulting ASCII value. I promise 3 more changes and I'm going to walk around. Hope y'all aren't that far behind, but if you are, I apologize for going far ahead of you. Okay, so our character 2 is equal to the ASCII value and the shift. But I don't want to calculate it that way anymore. And why do I say that? I just want to get a pure number. I want to get the ordinal value and then add the shift to it and then use some if statements in order to correct its value, whether it's too great to be on the ASCII table or too small to avoid it to be in the control characters. So what am I going to do here? I'm going to add the shift to it. AV plus equals shift, or AV equals AV plus shift. And if it's too large, I'm going to subtract that 95 from it. That doesn't sound right. My short-term memory is shot. Yeah, 95 is right. Okay. So, if AV greater than 126 colon, right, it's starting to go off into the character set that we don't want, then we're going to subtract 95 from it. AV minus equals 95. Elif, meaning else if, elif colon, elif AV less than 32, because that's the lower end of the table, AV plus equals 95. And now I need to redo that line, because since I added the shift earlier, this CH2 is equal to CHR AV plus shift. I need to just make that AV. So I'm going to edit this line right here. I'm going to take out the plus shift. I'm marking the fact that I'm editing that with a whole bunch of those. You don't need to add that. It's just for your eyes to key in. And there we go. Now to do a shift based on whatever this is, and it'll do it correctly. Those spaces are not going to be control characters. Those spaces are actually going to be printable characters at the end of the ASCII table. Right? So, if they became tildes, I love that name, tilde. So if I come look over here at my ASCII table.com, when I subtracted 31 from 32 and got 31, it added 95 to it to get a tilde. A space minus 2 would be 32 minus 30. You add 95 to it, you get 125. And so it should be a closed curly brace. Let's test that. I'm going to make my shift -2. And then I'm going to stop. All right. So I just changed that line as well so that it'll shift by 2 values. And there we go, right? The spaces became the closed curly braces. Everything is shifted down by 2 characters, but if it goes off the end of the table. So there's a common code for encoding text really fast, really simple, which is called ROT13, which stands for rotate by 13. It's just a Caesar cipher where everything gets added 13 to it, and if it wraps around, it goes back to the minimum. Why is it called rotate? Because you're rotating all your text on the table up by 10 characters, but if it goes past the end of the table, then it rotates back to the beginning, just like you're, walked past the end of the line, so you got back at the beginning of the line. That doesn't make much sense, but anyways, you get what I'm saying. If it goes off the end of the table here, it's supposed to come back up here. And I don't know who decided that 13 was the magic value, but the good thing about it is that if you would always know that you could ROT it by -13 and get back to your original value. And so if you were reading some kind of email, or when you see one of those buttons that says spoiler, and you can press the spoiler button and it'll expand it, to show the actual thing when you're reading a forum and somebody wants to mark that they're giving you the answer to Avengers 17. Right, and so old email programs would let you, say something like that, but then all the text would be rotated by 13, and if you click the button, it would correct for it. It was just a standard. So it was just a standard Caesar cipher. It's a quick and incredibly easy cipher to do. It's also quick and incredibly easy to crack, so don't think that you're making something magically difficult to crack by doing it. But, to the human eye, the text is now garbled. So when I run it, I will no longer be able to read, I love ZZ Top. Now we could also write this formula using modulus. We could subtract 31 from it, take the modulus of it, and add it back to, anyways. I figured it out before. I'm not going to figure it out this time because my brain works better in this case with if statements, just to adjust the 2 ends of the table. Now the book also shows a Caesar cipher, which I'm sure we will get to pretty soon, and it may not take into account the other ASCII values other than the alphabet. We'll see about that. And so then if you do a programming problem from MindTap that has Caesar cipher in it, they probably mean for you to do it the same way that it's in the book. But this is a complete solution because it allows for all ASCII text. Equals -2. It really should say something like shift equals int parentheses input parentheses quote shift equals question mark end quote in parentheses, right? Now I'm not going to actually put that line in there because that means for the next 40 minutes every time I run it I'm going to have to type a shift value. And we know that if we set shift equal to 0, that's one test you can always run. You will just get your original output, right? Just like that, because it's neither shifted up or down the scale. I'm just going to make it shift 1 because that's the easiest one to spot, right? A's become B's, B becomes C, and so on. Alrighty. So the first position, first subscript is 0, the second subscript is 1, all the way down to the last one, which is n-1, where n is the length, right? So the length of this one was 9, which is why it went 0 to 8. So name is equal to myfile.txt. Name subscript 0 colon. What are we doing here with this colon business? I love this textbook in some ways, but in others it seems like we're going to things earlier than what we needed to do. What they're doing here is they're taking what are known as subbed substreaks. I cannot believe I botched that. In Python, they call it slicing. That's the nickname that have been given to it in slicing. And what if you had, way down here, name equals Luke space Skywalker, and I just wanted to extract the first name. Here's what I could do. F, just for first time, is equal to name subscript starting at position 0, right? Because I want the L. And then how many characters do I want? I want 4 characters, so 1, 2, 3, 4. 4 plus 0, it's 4. And then if I print F out, it's going to print Luke. So that's a slice of it, right? More technically a substring. Why is it called substring? It's just part of a string. And what if we wanted the word sky out of here? Well, that's 3 letters long. What's the position of the S? I'm just going to count over. 0, 1, 2, 3, 4, 5. So starting at position 5 and going 3 more will get me the word sky. So F2, I don't know, equals name subscript 5, and I want it to go 3 characters. So 5 plus 3 is 8. Now there's another way to think of this second character. Just like a range statement, how this second character is one pass where you want to stop. This is the index of one pass where you want to stop. So what's the index for? If that's 0, 1, 2, 3, 4, that's the position specified by 4. And so we wanted to stop one past the end. That's one past the end. For Skywalker, this is one pass where we want to end. And what's the index of that? Counting them over. This gets a little tedious after a while. 1, 2, 3, 4, 5, 6, 7, 8. I think I goofed up. Let's find out.
Potatoes and rock.
Parentheses F2 in parentheses. I'm not sure I'm going to get sky out of that. Oh, I did. Okay, I had to have counted wrong. That should have been position A. And I think I started counting at 1. 0, 1, 2, 3, 4, 5, 6, 7. Okay, and one pass where we wanted to stop is 8. So just like the range statement, right? You want to count 1 to 9, you put a 10 there, right? If you want to count from 2 to 4, you put 2, 5. Well, in this case, see, that's why I like just doing the bit where I say, okay, if I want 1, 2, 3, 4 out of it, I'm going to add 4 to whatever this starting value is. That starting value is 9, I believe. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, that's starting value 9. So I'm going to just print that out. Print parentheses, name subscript 9, and if I want the word walk, that's 4 characters. So 9 colon 13 in square brace in parentheses. And now it should print walk. And I goofed it. Yeah, so it should not have been 9, it should have been 8. And you know what? I think I figured that out in my head, and I think I adjusted it to 9. It should have been 8, right? Because if sky ends at that spot, then this one should begin at that spot. And if I don't adjust this, how many characters long is that going to be now? 13 minus 8 is 5, so it's going to give me all the way out to E. Heck, let's just make it
14.
14 so we get Walker.
Wookie.
All right, and there we go, Skywalker. Now, if that was the case, if we wanted everything from here to the end, and we did not care how many characters it was, like, is awesome. What if I wanted this to say, Walker is awesome? Well, I don't want to have to figure out, you know, how many letters that is long and add it to the... If you take everything after the colon out, that means to the end of the string. If you don't insert a value there, it goes all the way to the end of the string. And so it says Walker is awesome because it went all the way to the end of the string. So that's a useful shortcut. Leave out the number after colon goes to the end of the string. Well, can you leave out everything at the beginning? Sure you can. Print, parentheses, name, subscript, starting at the beginning of the string and going up to but not counting specific value 6 in parentheses. That's the same thing as saying 0:6. Now, honestly, though, why not just to put 0 there? It's just as easy to type 0: as it is to leave that off. But it'll still work. It'll do what I just promised. Right? So 0, 1, 2, 3, 4. 0, 1, 2, 3, 4, 5. Right? So printed out characters 0 through 5. So if you leave out this thing before the colon, it treats it like it's a 0. Honestly, I don't see any reason to do that. What would happen, though, if I left them both out? Print, parentheses, name, square brace, colon, in square brace, in parentheses. So what's that first number, what's that first index equal to? If you leave off the index before the colon, what does it substitute in its little brain? 0, right? And what's this one? Go to the end of the string. So that's just going to be the whole string when I print it out, because this says, this means from 0 beginning to end. And so it did. Now slicing also works with lists as well as strings, because a string is in effect a list of characters. Now I'm going to define a list just so that I can play with it. L equals, and rather than make it words like I normally do, I'm just going to put Jenny's phone number. We're going to say that Jenny lives at 8, 6, 7, 5, 3, 0, 9. If you've ever wondered how that singer came up with that phone number, I know I'm saying it wrong. What's it called? Yeah, anyways. 8, 6, 7, 5, 3, 0, 9. I don't know why he didn't 4-2, do 4-2, but whatever, right? So anyways, just diagonals like that. And some of y'all don't even know what I'm talking about because you don't listen to music that's 40 years old. Anyways, oh, I forgot to print anything out, right? So if I want these 4 numbers, what's the index value of that 5? And this time I'm not going to count it out. I want somebody to count it out in their head. The first one is 0, so what's the 5? Right, 0, 1, 2, 3. And then I want 4, so 3 plus 4 is 7. So I'm going to say print, parentheses, no, that's not a parentheses, print parentheses, L subscript 3 colon, and 3 plus 4 is 7, end square brace, in parentheses. And it works just like a string. It starts at element 3 and it goes up to but not including element 7. So it's going to say 5309. And so it did. 5309. So everything we're learning here applies to lists, and it's probably even more important of a concept when you get to lists, because honestly, computers do more list processing than just extracting substrings. Same business. If I want if I want the last 4 characters, no matter how long the string is, then I would just start at 3 and I would put 3 colon and I would leave off the second number. And it would get everything to the end of the list. What if you want to see if something is in a list? You can use the IN keyword. Here's this syntax. If .text is in the file name, print file name. So we definitely have a U in our name, and so if quote U, lowercase u, because there's no uppercase u's in it, end quote, space and then the word in, if U in name colon print yes comma U, end quote, in parentheses. Are there any uppercase u's in it? No. So if I change this to an uppercase U, it's not going to print yes U. I'll prove that just by copying and pasting it and changing those little u's to big U's. All right, so that's a capital U, and that's a capital U. So this just searches the string. There's more than one way to search a string. Sometimes you care about the position of it. This is just returning a Boolean value, a true, false, a yes, no. But sometimes, like if I wanted to extract everything from the 5 on, I would need to know the position of the 5. I would need a function that would check this list and tell me the index position of that 5. And we'll get to that pretty soon. All right, and then yes, U. But it did not say no capital U, just because I didn't put an else in it, right, to indicate the incorrect. But I could have. Else, colon, print, parentheses, quote, no U. Sounds pretty childish. U, no U. All right, there we go. And so it's going to print yes for the lowercase u, and then no capital U. Right. So that's what the in keyword does. The way they did it is they had a list of words, and they printed them out if it found .txt in it. Because this uppercase, this string here can be more than one letter long. So if parentheses, quote, .txt, end quote, the word U, in temp.txt, end quote, colon, print, parentheses, quote, text file, end quote, in parentheses. Like that. So it printed text file. And if we'd searched for something else that wasn't in it, like .docx, if it was a Word doc, then it wouldn't print that. So, notes time. First index is 0 of a list or of a string. Last index is n-1, where n is the length of the string. Or last index is just -1, right? And then the next one is -2, and next one is -3, and so on. Slicing equals getting a substring or sublist. If we'd been talking about lists at this point, we would put sublist. And they did have a list, right? They had a list of file names. They swapped between strings and lists with reckless abandon, but I did the same. All right. So slicing S subscript 2:5 in subscript starts at index 2 and goes up to, but not including, index 5. The easy way to think about it is 5 minus 2. 5 minus 2 equals 3. So the substring, the slice, I'm going to replace that there. So the slice would be 3 characters long.
I don't think anybody's going to try to take that except the spaces right there.
And I forgot to close my comment with another triple quote, so I got a syntax error. I will fix that right now.
put one down and see what it does. I think it's going to crash.
Yes, if you index past the end of the string, then it's going to crash.
Actually, I put it up to shift up to it.
Oh, you're shifting? Well, what's that doing? It's like rotating around the map 1,000 times. Or 1,000 divided by 26, or whatever, right? Okay, so that is slicing.
Well,
that is indexing.
My cipher's undecipherable.
Yeah, it's probably pretty weird looking.
Because now I got these Greek things.
So many protocols have secure versions. This is going into your Cipher class, which people drop by my office asking for help writing a Python program that does a particular cipher from Ken's class, and that looks like a pretty hard class. I would not want to take Cipher without having had this class first. So it is easy to observe data crossing a network because an attacker can use sniffing software, right? They can check to see all the text that's going through, that particular wire, and they might be able to see what URLs you're accessing. And by the way, it is totally legal for AT&T or Sprint or your local service provider Cox to sell the list of all the URLs you visit from home. Now, if that kind of creeps you out, it kind of creeps me out too, because how many different things do you search for? Every search string, So
Google does the same thing too.
Yeah, so sometimes,
Facebook.
criminals get caught because of their search strings, right? Because if you Google up how to dispose of a body, right? And then, the FBI becomes wondering, if you did it or not, and they ask Cox to give you all their search strings. Anyways, so there is a new protocol that both Mozilla and Google and Chrome now use called encrypted DNS queries, to where whatever you type in here is encrypted before it is sent to the server that gives you the IP address to access. And then, I guess if you're going to do dirty deeds, you'd want to use a browser that was supporting that. Or you would want to do it from another machine. So anyways, encrypted text. Data encryption can be used to protect information transmitted on networks. Many protocols have secure versions. If you ever see HTTPS up in your URL rather than just HTTP, it means that as your browser asks the server for information, the server will encrypt it before it sends it to you, and then your browser will decrypt it. So one or more keys are used to encrypt the messages to perform cipher tests. A key is an essential component to decoding it and to encoding it. Caesar cipher is a really easy one. And there's another one called block cipher. What if you wanted to make our Caesar cipher considerably more difficult to crack? What you might want to do is say, instead of just shifting one, shift the first one by 1, the second one by 2, the third one by 3, the fourth one by 4, right? And that would considerably scramble the text. Now sure, some person at the NSA would run it through a program, and in 0.0 nanoseconds or whatever, it would get the answer right because it's not that difficult. But you could write a more advanced version of Caesar cipher that would be much more difficult to crack just by starting with the shift value and then adding 1 to it each time. And then when it needed to be decrypted, you'd start at that shift value and you would subtract 1 from it each time. Because that's how you decrypt something, right? Once this has been encrypted and ABC turned to BCD, you would need to subtract 1 from each character, right? So that the B's come back into A's. So let's say that.
Just shift it by 5,000.
Caesar, and I hope I said that, spelled that correctly. Shift the characters in the string by a specific value. And then to decrypt it, to decipher it, shift the characters in the enciphered string by the negative of that value. Now if we were awesome, we'd write a function that did Caesar cipher and ask for the string and ask for the shift value, and it would return back the enciphered string. And then you could test your algorithm by sending in that string and the newly decrypted string. Tell you what, we're going to do something like that. We're not going to make it a function now. But let's build a resulting string rather than just printing it out, right? Because we want to do something with the resulting string. We want to save it to a file or something like that. So if our original input, S is equal to, Bob is cool, end quote. We need to do the same thing that we did up here, and I'm almost tempted to just copy and paste it. Real tempted to copy and paste it. If you got this to work correctly, let's give a different shift value, right? Shift is equal to 15. Well, heck, whatever. There we go. And then up here, copy your for loop all the way down to, but not including the print statement. Take everything from that for loop, just scroll up and find everything in your for loop, starting with the word for, but skipping print. Copy that, and think to yourself, anytime I'm copying and pasting, I should have turned that into a function. Very true. All right, and then come down here and paste it. But instead of printing it, we need to add to it. So I'm going to say encrypted, encrypt. Okay, fine. I'm just going to type ENC. ENC text. I like the word encoded. I can spell that. Encoded plus equals that new character we got. Now what's wrong with this code? I'm going to get a syntax error. Pretty dang quickly. And I want somebody to say why it tells me that encoded is not defined. It's complaining about that line. What's wrong with that line? Looks like good syntax. But it says encoded is not defined.
You have to initialize it.
I have to initialize it to an empty string, yeah. So up here, above my shift, or as long as it's above the for loop, it'll be good. Very good, Nathan. Encoded equals empty string, because we're going to start adding characters to it. So let's print the original, and then let's print the encoded version of it, right? Print S, which is the original string, and I should have given it a better name than S. And then print, print the encoded version. But now let's decode it. Yet again, I'm going to copy all this and paste it, but I'm going to make the shift -1000. So I'm going to copy all this stuff. Everything from underneath S is cool, Bob is cool. We don't need to redefine S. But I'm going to copy all of this stuff right here from there to there, from the encoded equals quote line all the way to the end of my for loop. And I'm going to paste it, but I'm going to make the shift the negative value so that we can decrypt it. And I don't want to call it encoded anymore. I want to call it decoded. So on that copy and paste, I hope this isn't too much copying and pasting, but it is in the notes. Decoded. I really should have written it as a function, right? And then I need to add decoded there. So I just changed these two lines. These were the only two lines I changed. Oh, and I don't want to erase encoded anymore, so I should delete that line. So this is in the second copy paste. What have I just done? I goofed on that. That's the line I need to change. So one above shift equals -1000. I'm going to make that say decoded there, and then the last line of my for loop, I'm going to make it say decoded there. Why? Because I'm building a new string so that I can print the decoded version and compare it against the original. And then let's print that out. Print parentheses decoded in parentheses. Now just printing out what it is, the contents, is kind of lame. So why don't I add some extra information in my print statement like this? Print parentheses, quote, original, colon, end quote, comma, S. And then the second print statement, I'm going to make it say encoded, colon, but I'm going to add a space after it so it lines up exactly. And then down here, I'm going to add that one more word to my final print statement, decoded, colon, space, end quote, comma. All right, with all that copying and pasting and changing, I sure hope I don't have any syntax errors. And I do, great. All righty. I should not have used 10,000. Let's fix that. Why don't we just change this to a shift value of 10?
It was
and then make this a shift value of negative 10. And see if we're better off. Well, my algorithm stinks. I encoded it correctly, but when I tried to decode it, L turned into A. V turned into B. I wonder what I did wrong.
I think I got a bigger problem.
Okay, my last effort at this. Oh, you know what I did wrong? That line. What I did is I shifted the original code, not the encoded version. Last change, I promise it'll work here. So that 4CHNS colon, I'm changing that line now. I'm flagging it, make it real easy to spot. For every character in the encoded text, shift it by the negative amount. All right, I'm glad that one wasn't, I didn't have to waste much more time on that one than that. Okay, so I got the original. It was encrypted, enciphered, encoded by positive 10. I shifted it by positive 10, and then I used that as input for the shift algorithm, and we got the original text. Hope that makes sense. And I know I've botched y'all by copying and pasting too much. Let's see how many people I can read. All right, I will upload these notes, and if you're frustrated that you weren't able to get it to work, I'll also print them out for anybody who needs them. So, what are we gonna do?
I would like mine printed out. Mine's doing something wild.
We're gonna take some string here. S is equal to when in the course of human events. I want you to use slicing to print out one per line when in the course of human events. So just for example, just to make it easy, I'm going to do the first two for you. Right? So what would the first one look like? Print. What's that position? That's 0. So S subscript 0 colon. And how long is that word? 4. So 0 plus 4 is 4. That'll get when. Right? And then what's that position? Well, if that's 0, 0, 1, 2, 3, 4, 5. So starting at position 5 and getting 2 characters. So 5 plus 2 is 7. Print parentheses S 5 colon 2 end parentheses. That'll print out if. Yeah, that's right. You caught me. Thank you. That should be 5 plus 2 for 7. All right, so there we go. Right? When in. Do the rest of it. Now that may be too boring for you because you could probably get this homework done in about 2 minutes, right? By doing the rest of this. So, extra work. You're going to get double credit for this assignment if you find a way of doing this in a loop. And I don't care, and this is the only time I'm going to ever say this, if you Google the answer. Any way that you can figure out how to do this with a loop. How would you do that? You would need to search for the position of the first space, search for the second position, search for the third one, search for the fourth one, the fifth one, and the sixth one. That's one way. There's another far easier way to do it. I'm not going to even tell you the far easier way to do it because I want you to do some Googling. Right? Only time Googling is okay is when Prof says go for it. I don't care if you just copy and paste the answer as long as it prints the results, right? But the key thing is it has to do it in a loop.
Oh, so you just want us to keep that string, just print those when in the course, like.
Right. I want you to do the same thing, print out all those words, but using a loop for the extra credit.
Oh, okay.
All righty. Let's stop here.
Mine was
I'll
doing
print the
something
notes out for
crazy,
anybody
though.
who wants them.